Okay. I think I have this back up, but I need to, let's see here. I started a new stream, check my YouTube page. So I gotta close this, and then I gotta open this one. Yeah, I don't know why it does this on occasion. Only with YouTube. I have not had this issue with Twitch. Okay. So I do need to give people a little bit of time to come back in here because there's only like 5 people in here so far. And then I do need to post in here, new stream is up. This is what happens. I rickroll the class and then I immediately, my OBS crashes. So part 2, we'll call it that. Visibility public. I'll put this in a playlist later. Okay, sorry about that. So if I notice fast enough and I close OBS and then open it again and start it, I can maybe reconnect to the stream. I totally didn't do it in time. Like, as soon as I hit go, it said, stream is over! And I'm like, thanks, YouTube. Why don't you give me, like, 60 seconds or something? Okay. I have this little box in the corner. You can't really see what I see, unfortunately. But there's a box and it's green, and if it ever turns red, that means that everything has collapsed and died. So yeah, we were working on these problems before the crash, and what I want you to do is keep working on them. I'll give you like 1 or 2 more minutes. I'm going to mute myself until we go over the answers. But go ahead and answer these questions on the screen. Sorry, some of these messages YouTube's going to flag as like spam because it looks like everybody's spamming the chat with random numbers to a bot anyway, but this is actually what I want you to do. All right, we're going to go to the answers. If I can find my pen here. Here we go. All right, so how many digits are... That's not the pen tool. There we go. How many digits in this number of hits are significant? Well, all the non-zero ones for sure. And then the other zeros are just trapped in there, right? So they count too. So this would have 9 sig figs. And for anyone who didn't click on the link, it's probably better that you didn't, because it was a very famous 1987 song from someone named Rick Astley about never giving up or something like that. I don't know. How about this one? So here are my numbers that are non-zero. I made this joke in like 2007 when I first started teaching, and then I guess they brought this show back? Like, what the hell? Anyway, this zero right here is trapped in between these two. But this zero right here is not. This is a placeholder. So there are only 4 significant figures in this value. I don't know about 98201. That's like an Everett zip code. That seems like it'd be even more lame than 90210, but I don't know. Now, that's a good question. If YouTube counts the exact number of views, would that zero be significant? It turns out yes, and we're going to show why that is in just a second. However, we're just assuming that all of these numbers as written are measurements. For instance, 90210 is technically a zip code. That's not really a measurement. And zip codes are discrete, right? Like, you can't have a zip code of 90210.47. So we're assuming these are all measurements. For this mass of a flea, this is absolutely a measurement. These 2 digits are definitely sig figs. And then we apply the decimal rule. Anything to the right is a sig fig. Anything else is a placeholder. So there's only 3 sig figs here. And then same thing for this one down here. This is a sig fig. There's a decimal. All the other digits are also sig figs that are to the right. All right, now to answer that bottom question over there, what would the uncertainty be for each of these digits as written? And so if we were to take all of these, actually, let me go over to this view here. That had to load for a second. All right. So if I was going to make tools out of these, oops, I didn't want to do that. There we go. This first one's kind of a pain. But we could do it. So 744053. Wow, my technology is just not working with me today. In order to get this number as written for the number of views, if I had a scale that measured every 10, and my object went to about here, we'll say, I would write down the smallest mark, 74405305, and then I guess the next digit. There you go. Yeah, so 90210, the first 4 digits are sig figs because the non-zero digits are sig figs, and that 0 between the 9 and the 2 is trapped, so it counts 2. It's known for sure. But that last 0 is a placeholder, and we'll show that using this. Ooh, that's terrible. Sorry, my hand kind of got caught on something there. So if I had a device that looked like this, maybe it just doesn't like the number 3. I don't know. So if I had this going on 902 or 90,200, 90,300 for my scale, and my object was like right here, I would do this, write down the first mark, and then guess the next digit, which I'd guess to be that. And if I just stopped there, this number actually doesn't fall in this range. 9,000 does not fall in the range of 90,200 to 90,300. So I need this placeholder 0. That didn't even show up. There we go. And if I don't have that, then my number doesn't have the right magnitude, right? So that 0 tacked on the end is not known. It's just a placeholder. And you could do the same thing with the flea. So if I did this and my object fell right here, I'd write down the first mark and then guess the next digit. Well, I landed right on the mark, so I would measure it to be that. And then for the decimal point one, you can actually imagine a tool that looks like this. Lands right on the line for 500, so you'd write down, it goes to the tenths place, so I would write down the first 2 digits, guess the next digit, and go, well, wait a second, I know this for sure. I need to write this in a certain way that gives me sig figs, and that's where the dot comes in. The alternative to this is to use scientific notation, and we'll get to that in a little bit. All right, there's one more thing I want to do before we move on to the next section and also take our break here. And that is to look at these scales just a little bit more. Oh, sorry. Well, we also have to talk about exact numbers and inexact numbers. Now, you might remember that when we were talking about exact numbers, these were things like counting, right? Or a definition. If I counted the number of people in the stream, there would be no error in that. So it says there are 23 people viewing right now, which for a lecture on number theory is actually really good. Now, that said, what if I wrote this as the number of people in the stream? Would it be accurate? And I just kept writing zeros forever and ever and ever. And yeah, you could absolutely say that. Because people are discrete individual units, right? You can't have a fraction of a person. So an exact number which would be something that is counted or defined, has an infinite number of sig figs. So if I gave you a bag of marbles and you said there were 52 marbles in here, there is exactly 52. It would have an infinite number of sig figs. So yeah, in your previous question, how many sig figs does the number of viewers of Never Gonna Give You Up have? If it is a counted number, it would have an infinite number of sig figs because it wouldn't be wrong. Now, for that exercise, we were working on the assumption that they were measurements. And I don't actually know if the slide says that, so I might have to go back and reword it. So we're sort of putting all of this together, right? We're saying, okay, is the number exact because it's something we've counted or defined, or is it inexact because we've measured it? And then based on that, we're going to work with sig figs in the appropriate way. Olivia, you had a question about the last question. Can you be more specific? Do you mean the 500? While you're typing out, I'll type a response in the chat here. I'm going to give you these graduated cylinders here. We're going to work backwards now. I'm going to give you the number And I want you to tell me which graduated cylinder gives me 540 is the answer, okay? So these are 3 graduated cylinders, all with the same amount of water in it. But each one has different marks. Which one correctly gives you 540 is the number you should write down? A, B, or C? And then try and explain why in the chat. I'm going to give you a minute or two to do that. And then we'll go over the answer, and then we'll take a break. All right, it looks like everybody gave an answer. Everybody said B because A doesn't give you enough information using our rules here. So that's not 0. That's 100. I don't know why that line is right there, to be honest. So if the bottom here is 0 and this has a mark every 1,000, we would report 0,000 and then just guess this to be 5 and then put placeholders. So this would just be 500. There's only one sig fig there. It's this one. This one right here, we would follow the measuring rules and guess the next digit. Or I guess in this case it'd be 540, huh? So this is 2 sig figs, which is what we want. But over here, I would write down the first mark and then guess the next digit, which would be something like that. Yeah, tube C is too precise. So again, you can see more marks between our places means that we can write down more digits. All right, I'm going to advance the slide real quick to here. This is where we're going to pick up after the break. It is break time. I don't have a timer up, though, so I got to get that real quick. Let's see if that pops in there. Oh, it did. Okay. So I'm going to start the timer here, and we'll get some music going. More Persona 5.
Who am I? I'm no more art. And as I look to the horizon, not a cloud, but then stormy weather's go too cold. Seems like it crept up out of nowhere, all around you is not what you foretold. You never see it coming. You see that my mind is too fast for eyes. You're done but the time it hit you, you're not surprised. Think you got your game planned out. Do it, get 'em 2 steps ahead, yeah. So step into my way, stand out. It's a trap, one more step, and you're dead. Why just a big second ago with blue skies and now lightning like your last result? It's not an accident that no one hears your cries as your last dream seems to deserve. You never see it coming. You see that my mind is too fast for eyes. You're done but the time it hit you, you're not surprised. I'm coming for you. My game's always so fast, so fine. You're spanning, but the net you didn't catch it in time. Better think about your game. Are you sure your next move's the right one for you? Are you sure you won't get outmaneuvered again, my friend? You never see it coming. You see that my mind is too fast for eyes. You're done but the time it hit you, you're not surprised. I'm coming for you. My game's always so fast, so fine. You're spanning, but the net you didn't catch it in time. Where have you been searching all along, confessing twilight on and on, without a clue, without a sign, without grasping it. The real question to be asked: where have I been? I'm a sharpshooter, Apple's masquerade, hiding both face and mind, all free for you to draw. I'm a sharpshooter, what else should I be? Please don't take off my mask, revealing dawn. right in front of me. That's where I find an empty glass, reflecting that's a truth. It's telling words not to be told. I need that mask. I'm a sharpshooter at post masquerade, heart in both face and mind, all free for you to draw. I'm a sharpshooter, chained down to my core. Please don't take off my mask, my place to hide. I can't tell you how to see me. Just a cage of bones. There's nothing inside. Will it unleash me, burning down the walls? Is there a way for me to break? I'm a sharpshooter at post masquerade, heart in both face and mind, all free for you to draw. I'm a sharpshooter, have no face to show. Please don't take off my mask, my disguise.
All right, we are back. Perfect timing on the music to just fade out for me. Don't have to do anything. Yeah, to answer one of the questions in the chat, I sort of just pick random music every week. Sometimes I pick games that I'm playing. Other times it's just like, oh, I like the music for this. I will just do that. I know one of the weeks, and this might be relevant to the person that asked the question. I do Zelda Wave, which is like lo-fi chill wave of Ocarina of Time and Majora's Mask, and it's super well done. What else do I do? I do a Stardew Valley week because the music from Stardew Valley is really good. But mostly just games that I've played. Also, stuff that isn't super recent that won't get copyright takedown notices because some game companies do that with their music. Okay, so now that we've covered how to do sig figs on just any measurement that is taken, now I got to do stuff with those numbers, right? For instance, if I give you the length and the width of like a rectangle, you could multiply them together to find the area. But what if I gave you the rectangle and I said, well, tell me its area. Oh, and here's a ruler. Then what you'd have to do is you'd have to use the ruler to get a number and then use those numbers to get the correct answer. But in your measurement with the ruler, error is introduced, as we showed with the uncertainty. The last digit is slightly unknown, and you can't just write down zeros forever. You don't know what those numbers are based on the tool you're using. So is there a procedure that we can follow? And it turns out there's totally a procedure. We're going to do two generic examples here of problems that I know every single person in this class can do. Everyone knows how to add numbers. And even if you don't do addition like this with your hand and you punch in the calculator, you could do it the long way if you had to. Same thing with the area problem. What do you do for the area? You multiply the numbers together. You'd punch it in your calculator and you'd be done with it, right? Well, we're going to add a little bit of a hiccup to that. And that hiccup is, in each of these digits, the last number is uncertain. How does that affect our calculation? Now, I'm going to do this on this page right here, and this is kind of what I want you to do in your mind. Maybe not as poorly as I did. I'm trying to move the tablet to various places to see if it helps me write a little better. I actually kind of like this, but it's to my side, and I'm looking at the screen, and I'm not looking at where I'm writing. What if I do that? Now I'm not looking at the screen, so I don't know what I'm doing. We'll just get rid of those two. Whatever. Anyway, this line is important. And the line is separating the addition side from the multiplication side because, and here's the kicker, different operations have different rules. We're going to learn the addition rules first, and then we're going to learn the multiplication rules, and it'll be your job to keep those rules straight in your head. You do not want to mix them up. Do not confuse them, or else everything you do with your numbers will be wrong. And that would be terrible and awful. So let's start with addition, and we're going to talk about what we do. Now, the first thing we're going to do is we're going to look at these numbers as if they're measurements. Remember that if I were to make this measurement and get a number to the 10th place, that means that my marks were every 100, right? So if this is 352, and this is 353, and my object went all the way to about here, we would write the first mark and the next digit. But the next numbers after this, all these numbers that come after it, we don't actually know what those digits are, do we? These are all ambiguous. Now, when you have done addition in the past, like in first or second grade, what they do is they teach you, oh, just treat these as zeros, right? Just fill in the zeros and add straight down. But in science, we don't know what those zeros are. In fact, they're not zeros. They're question marks. And 1 plus question mark is not 1. Instead, it's question mark, right? So if I do this addition, these numbers end up getting lost because I'm adding some unknown thing to it. They could be any number. It depends on what these question marks are. But this one over here could be an 8. It could also be a 9 if this had to carry the 1 sort of operation here. And the rest of them are known because all the digits are known at that point. So I could write down the answer, right? So here's the procedure that we're going to follow for addition. And to answer your question, addition and subtraction follow these rules. Because subtraction is just adding negative numbers to positive numbers, right? You follow the same rule. So here's how we do this. What we're going to do is we're going to start from the most precise place, which is to the right. So this is the precise side. As you go towards this direction, numbers become more and more precise, right? So could they all be question marks? If you're talking about over in this position, like say over here, then yeah, and we wouldn't write these numbers down at all. In fact, we would start writing numbers down right here. If I understand your question correctly. And so we're going to do that in practice here. We're going to look at the most precise position and work from right to left. And we're just going to go doot, over towards the left until we hit a place where there are digits in every spot. So let's look at the thousands place here. Is there a digit in every spot? No. So we cannot write a number in this spot. How about the next spot? The hundredths place. Is there a digit in every spot? No. What about in the tenths place? Hey, there is a digit here. We're going to start our addition from this spot when we keep our numbers. Oh, I see. How do you know whether this is an 8 or a 9? How do you know if it was carried? We're going to actually deal with that right now. So what we're going to do is we're going to end up rounding. This is the position that I found that has a digit in there. So what I'm going to do is I'm going to circle that spot. And then what I'm going to do is I'm going to do the addition like we've been taught all along, which is treat the blanks as zeros, right? So I'm going to have a 1. This becomes a 2 with a 12. And this is where your carry comes in, your carry operation. So this actually becomes a 9, which is what you'd expect. There's my decimal point. So I carry the 1 here. Carrying lots of 1s, actually. And this is the result that I would get. 535.921 if I added these normally. But the boxed number is the last digit we're going to keep. We're going to trash all the remaining numbers. Now, a rounding operation may have been required if the numbers were bigger. So if I landed on, say, a 7 in that, if this digit right here in the first position we trashed, if this was like a 6 or something, we'd have to round up or down based on what number we got there. But we are only going to report to the decimal that all of our numbers contain. All of the numbers that we are doing an operation with have a tenths digit. So I'm going to report my number to the tenths place. And then I'm going to round based on what the next number is. Now, your text mentions bankers rounding. Bankers rounding is frustrating and not super useful for chemistry. The reason being, bankers rounding is great for averaging large amounts of data points. But in chemistry, we don't work with large amounts of data. We don't work with statistical analysis and stuff like that because we're really only doing 1 or 2 experiments. So we're just going to do traditional regular rounding. And traditional rounding is, if I'm going to round this digit, or from this digit, if x equals 0 to 4, then we truncate. But if x is 5 to 9, we round up. So in other words, oops, I lost the cursors here. So 4.4 would round to just 4 if we were rounding to the 1s digit, but 4.6 would round to 5 if we were doing the 1s digit. Same with 4.5. So for regular old rounding, don't do bankers rounding. So don't round to even on 5. Always just round to 5 up. 0 through 4 get rounded down. 5 through 9 get rounded up. There will be a slight bias towards increasing numbers. However, we are only working with 1 or 2 data points anyway. And so rounding towards even versus rounding towards odd doesn't really give us any statistical advantage. And it's just an extra step that everybody gets confused on. And Canvas tends to be rather picky about your answers. So don't do it. Just round to normal rounding rules that you've been using. All right, let's do some more examples here. Using the addition and subtraction rules. All right, I got to clear the Photoshop real quick. So, boop. And I actually have an idea of why this might be chugging along here. So let's see here. Canvas size. What is this in pixels? I do not need 4,000 by 4,000 pixels. That's a little bit absurd. There we go. Yeah, because this is at 62% zoom. Oh, a friend has arrived. Do you want to say hi? Hold on. Would you like to say hi? Say hi. Say hi. Say hi. I don't know if you heard her. My cat has decided that it's time to pay attention to her, but she's wrong. It is lecture time. Oh, you heard her. Oh, good. They heard you. Okay, good. They heard you. My cat loves people, including virtual people that she's never met. She knows you're there. All right, so we're gonna apply the precision rule. Which position are we gonna round our result to? So I'm gonna start from the right, and we're gonna work our way to the left. So I'm gonna look at the hundredths place. There's no digit here though, so I can't use the hundredths place. Let's look at the tenths place. Hey, there is a digit in both spots, so I'm gonna round my result to the tenths place once I'm done. Now my eraser's too big for this operation, but that's okay. All right. So now let's do our subtraction like we normally did. So 3 minus a blank would be 3. 8 minus 7 is 1. 4 minus 0 is 4. So there's my answer, but I need to round it to the tenths place. So this number would become 4.1. All right, so there's our answer. Oops, sorry, I didn't hold down a button there. All right, let's do another one. Now, you're going to notice that as our numbers start to get a little more spaced apart, weird things begin to happen with these rules, and this is actually intended. That's wrong. Hold on. All right. So, again, let's do the same thing. We're going to look for sig figs in each position. So we'll start at the thousands place. And there's not a sig fig here, so I can't use that number. How about the hundredths place? Well, no. How about the tenths place? No. How about the ones place? And you might say, well, yeah, there's a 0 there. But that 0 is a placeholder. Placeholders aren't sig figs, so this 0 doesn't actually mean 0. It's just a placeholder, right? So this number does not actually help us. We don't know if it's actually a 0. It's been rounded, because 7300 only has 2 sig figs, right? So I can't use the ones place, nor can I use the tens place. The first place I can actually use is the hundreds place. And so when I go to write my answer here, all these numbers right here are just going to get carried down, but we're not going to be using them. And so now I'm going to round to the indicated place, which means that I write that and then some placeholders, and that's it. Now, that seems kind of weird. Where did all of our numbers go? Well, the shitty number, which is 7300, has very little precision to it. It's measured very crudely. And a crude measurement and a very precise measurement added together gives you a crude measurement, right? If I know something very precisely, I have a lot of accuracy in there, and then I lose all that accuracy because I added to it a bunch of question marks. Now I don't know what those numbers are anymore. Sorry, I'm playing around with this in the background here so that I can don't have to switch back and forth. All right. Now this is the example that makes everybody hate doing sig figs with numbers. Or with addition, I should say. If I add these two numbers together and I say, okay, I'm going to look for which position we round to, well, there's no digit here because this is a placeholder. Placeholder, placeholder. So the first digit I have to round to is the thousands place. Now, we actually know that these digits in front are zeros, for sure. So I have 0,006, in other words, but nobody says that, right? So those zeros are known. We're not going to track them as sig figs because otherwise we would have infinite sig figs because there's infinite zeros before that. But they are known. So when we do this analysis of which place has a known digit, the first one that we come up to is the thousands place. So when I do this addition here, I get this, but I have to round to this position. And so what that means is that in this class, 3,000 plus 6 is 3,000. What the hell, right? But if you think about it in certain ways, this actually makes a lot of sense because of how precision works. Let's do another example. Suppose that you are buy a Powerball ticket and you win $656 million. It's a lot of money, right? Now, you've cashed the check and you have all the money in your account and you're like, holy shit, I don't know what to do. You're new to this millionaire thing, so you do what sounds good. You go to Taco Bell and you buy a few tacos for $4.99. Oops, not that many zeros in the price of a taco. Oops, there we go. How much money do you have left? Is it 655,999,994? No, you don't give a shit about these numbers anymore, right? After buying your $4 tacos, you still have $656 million, right? This number is too small to affect these digits. If the places are way too far apart, you get odd results like this, where you do the subtraction or addition, and functionally nothing happens. Here's another example. The population of Seattle at some point in time was about 750,000 people. And then over the weekend after that measurement was made, a family of 5 moved in. What's the population of Seattle? You would still estimate it to be 750,000 because clearly this estimate was made to the 10,000s place. And a family of 5 is not going to topple that to the next 1,000 or 10,000. So this is why these outcomes occur how they do. If your numbers are just too far apart in terms of their magnitudes, you get weird results. However, this is working as intended. Okay? So make sure you note that. All right. That's addition. Any questions on addition, let me know. Now we're going to do multiplication. Now, I'm not going to actually draw out the problem with all the question marks in here. But you get the idea of how this multiplication is going to turn out if I did the whole thing. That's a really good analogy. If you have a 5-gallon bucket of water and you pour a shot glass of alcohol into there, technically there's alcohol in there, but there's very, 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 very little. So little that it does not affect the overall volume of the container to any appreciable degree. Now, if I were going to do the long multiplication for this problem, we all know how to do long multiplication, right? You multiply all the digits times the first digit, so you get a bunch of numbers, and then you put like an X here, and then you do all the multiplication, and then you do this, and you just keep doing this over and over and over, right? Well, anything times question mark would be question mark. So I'm going to get all these question marks when I do this. And it's not until I start this next row down here that I'm going to start getting actual numbers. But most of those numbers are going to get chopped out because of all these question marks, right? This is all rubbish. Only the numbers that make it over here when we do the last step, which is addition, would make it. Now, I could do the entire problem to show you what your result would be using this strategy, but that takes way too long. Nobody does long multiplication anymore, right? We teach this to you in like 3rd or 4th grade, and you can do it, and then you never do it again because you go and buy a freaking calculator, right? So we're going to develop a method that more or less takes that into consideration and gives you the result at the end. And this is the multiplication rule. Note that multiplication and division follow the same rule. But this rule is unique compared to addition and subtraction. So be careful. Multiplication and division follow a different rule. They don't look at places. Addition and subtraction look at places. We do that place thing where we start on the right and we move left. Multiplication and division do not do that. Multiplication and division look at the number of sig figs instead. So what we're going to do is we're going to look at the number of sig figs in each of these numbers. So this first number right here, how many sig figs does it have? Well, all of these are non-zero. So this must have 6 sig figs. For the second number right here, there are only 2 digits, and they're both non-zero, so there must be 2 sig figs. Then what we're going to do is we're going to determine which of these measurements has the fewest sig figs. That's this one. So our answer will have this many sig figs. And then finally we punch it in the calculator. So let me clear all the ink on my slide here. So if I punch this in the calculator, this is the number the calculator spits out. But due to the fact that one of the numbers we used only has 2 sig figs, my answer is going to get rounded to 2 sig figs. So I'm going to round this to 2 sig figs. And that's the answer I would report. So multiplication and division, easier process. Just punch in your calculator, then round to the correct number of sig figs. Remove digits or add zeros as necessary. So let's do some more examples here. Oh, well, I guess we're going to do a combined problem. Hold on just a second. Let me see what's... Oh, I don't have the slides in here. Okay, that's fine. That is pretty straightforward, so we can do that anyway. Now, if you have both operations, what do you do, and how many sig figs should the answer have? Now, you might look at this, and you might already be making assumptions. You might say, oh, okay, well, this number has 3 sig figs in it, so I bet my answer is going to have 3 sig figs in it. And guess what? Totally wrong. Because you're not doing only multiplication and division. You're doing addition and subtraction. So if you have both operations present, you have to do order of operations. Right? I wrote this the wrong way in order for me to... There we go. So we all know the order of operations, right? It's parentheses, exponents, multiplication and division, and addition, subtraction. And these are grouped together. And we all know the mnemonic, right? Please excuse my dumb ass sibling. This is the one I learned. So, if that helps you remember it, then all the more power to you. They don't teach you this one in elementary school, though. Now, to be fair, I did just make this up. But what this does say is that we have to do these operations in this order, right? So I can't just do the multiplication first. I have to do what's in parentheses first. So let's do that. So if I do this subtraction right here, yeah, everybody learns about Dear Aunt Sally, but it turns out Aunt Sally doesn't know how to do very much math. Like, why would you excuse your Aunt Sally? Like, what has she done? She's just trying to live her best life, but your dumbass sibling, like, screw that guy, right? Or girl. Or whatever their gender is. I think I made that up because I loathe my brother. My brother is a total ass, and so that mnemonic is for him. Anyway, we're going to do the subtraction here. And I can't round to this place because I have a blank. Can't round to this place because I have a blank. But I can round to this position right here. The 10th place. So that's where I'm going to round to when I'm done. So we'll circle that. And we'll get a different color because it's starting to get confusing here. So now I'm going to do the subtraction as if these were zeros. So this becomes a 7. 9 minus 8 is 1. 7 minus 9 is 6. And then 3 minus 0. Oh, sorry. This becomes a 2. So that's what I get for my subtraction. And you can verify that by grabbing a calculator and punching it in. In fact, you could verify that I'm wrong. This is actually an 8. There you go. Now I feel like I need to verify on the calculator because I can't do subtraction without actually doing all the work, so. My calculator's asleep. My calculator's my phone today. I gotta find my TA83. 2.817. Okay, that's right. Cool. Okay, but due to the subtraction rules, I am going to round this number to this. And so I would put that up here. This is now what goes in this spot. So this is a 10 right here, but in order to make this 10, I had to borrow from here, so this becomes a 9. So the first one's 10, but after that, all your blanks become 9s because you have to borrow the 1 from each one. And in order to borrow that one, I have to borrow 1 from here too. So on and so forth. Long subtraction sucks. No, it's okay. When I looked at that, I was like, wait, did I do it wrong? No, I just punched in the calculator. It has to be right, right? So this is all ancient technology, right? Like, we haven't thought about this forever. But the point is, when you do set it up vertically, you're going to get the number of places to be in the 10th position, which is right here. Now, that's going to affect your result when you do the operation, because now you get this as your answer, right? And when you do this division, and you apply the division rules, now you're going to say, oh, there's only 2 sig figs here. This has 4 sig figs. Notice I saved that 2 I was writing into before. My answer when I'm done is going to have 2 sig figs. And so this is the result that I actually write. Why did that disappear? I don't know. Now, if you'd looked at that and said, oh, okay, yeah, that answer is going to have 2 sig figs, I would say, oh, you read ahead and know what the slides are going to say, because you wouldn't guess that a number with 3 sig figs subtracting a number with 5 sig figs divided by a number with 4 sig figs would have a number of sig figs that isn't even present in the problem. But because of how the rules work out, this is your answer. Okay? So be very careful when you are doing combined operations. You can't just put it in your calculator and then say, oh, well, I'm doing division, so I'm going to just pick the lowest number of sig figs. Because addition and subtraction follow different rules. So whenever you see addition and subtraction, do their rules, and then do the next thing, and then do the next thing, and so on. Okay? So make sure you're following the order of operations, because if you go out of order, you get the wrong answer, and you get the wrong number of sig figs. This page just talks about rounding. This is standard rounding. You do not need to round to even in this class, or do bankers rounding. Those are the same thing. We're just doing standard rounding because, again, we're not doing statistics with our numbers. We're not really going to introduce a ton of error. So it doesn't really matter for our purposes. If we were doing like 75 trials, I would say, yeah, let's learn to do bankers rounding. But when you're just doing regular old rounding, just do it this way. It's fine. Last thing to talk about. If you type in a number in your calculator doesn't know what sig figs are most of the time. Now, some TIs come with a program that lets you do sig figs. Most don't. I think one of the 3 TI-83s I have around my apartment, yeah, I have 3 of them, has that on there. It came standard. But a long time ago in like 2000, like I have my calculator from college somewhere. They didn't have that on there. Yours might, I don't know. Don't trust your calculator to do sig figs because it might not know them. Here's a good example. If you type in these 2 numbers in your calculator, what your calculator does... Let me see if I can find an online TI. Let's see if I can find one. Is this that one school that like there's like a K through 12 school. Yeah, here it is. Oh, maybe this isn't it. There is a virtual calculator. I might have to find it sometime. But the point is, when you add these numbers together in your calculator, it should just spit out this result. 8. Oh, they have an emulator on there. Okay. I'll have to download it and get that at some point, because I can capture that really easily. That'd be helpful. But if you type in your calculator, this is the number it spits out. Where if we do the addition vertically, we know that, oh, I can work to the thousandths place because there's a sig fig in each of those numbers. So 2 plus 8 is 0. 6 plus 3 plus 9 carry the 1 is 0. 3 plus 6 plus 9 carry the 1 is 0. So this is the correct answer that you should report. 8.000 with 4 sig figs. But your calculator will just print out 8. As if it was something out of the Stanley Parable or something like that. So be careful. The moral of the story is your calculator doesn't necessarily know what sig figs are. Most calculators don't. Some do. However, for most people, it's not practical. They don't care about sig figs. They just chop off all the numbers and round however the hell they want to. But we actually care. We care a lot in science. So don't rely on your calculator for sig figs. It will do them wrong. Your calculator tries to chop out all the zeros it doesn't need, and it only has a finite amount of space to print numbers on. And it may print weird number oddities depending on how many decimal points you have. Like, for example, if your calculator only holds 6 decimal points, it may print 0.000002 as your answer, and you might need more sig figs than that. That's where scientific notation comes in, which is the next page. Now, if you have a calculation and it has an exact number in it, remember what exact numbers do. Exact numbers have infinite sig figs. My pen didn't select there. If you use an exact number, it will never affect your precision because a number with infinite sig figs will always be more than the other number in your calculation. So if you said exactly 2 times 5.3, your answer would have 2 sig figs because 5.3 has 2 sig figs. If you did addition, exactly 2 plus 5.3, your answer would be 7.3 because you'd go to the tenths place. All right, so I got a bunch of examples for you. What I want you to do is I'm going to give you 5 minutes to try these. We're going to run out of time before I can go over the answers completely. But go ahead and try these for a little bit, and then I will put the answers on the screen. We'll go over as many as I can before we run out of time. And then everybody has probably seen scientific notation, so I'm going to more or less skip it. But we'll talk about what that means at the end of the period for the quiz, which I'm going to put online tonight. So I'm going to hit mute. Go ahead and work on these problems. Type your answers in the chat as you get them. I'll see you in a bit. All right, we're going to run out of time. So what I'm going to do is I'm going to write all the answers on here. We'll go over the answers to these next time, but I do want you to all have the answers available. And if you have immediate questions that you'd like me to answer, I can answer them in the Discord or on lecture tomorrow. So I'm going to just write down the answers here to each of these. So that is... looks like that. Hitting the wrong key. There you go. All right, so those are the answers that I got for all of them. So double check your addition and subtraction and multiplication and division rules if you have any mistakes. I'm happy to go over those, but we're going to run out of time if I start them right now because I can't do these all of them in 2 minutes. So we'll start here tomorrow. For the last 2 minutes, I do want to talk about quizzes. So what's going to happen is after today, after this lecture is finished and I go off the air, I'm going to go into Canvas. I'm going to put the first quiz online. You could take the quiz today if you want to, but you get a week to do the quiz. So for quizzes... So if it opens today, and today is Monday the 27th, then it will close in 1 week, which would be Monday. Well, actually, I shouldn't say close because it's due. So, like all assignments in this class, with the exception of the exam and the final, it's due a week from today. So that would be 27, 28, 29, 30, 31, 1, 2, 3. So that, I think that's right. I think it's the 3rd of October. I don't have a calendar in front of me. And then it would close. So the absolute deadline would be, it closes the next day. So you got to finish it by the latest on October 4th. So all assignments have a 1 week period for you to work on them. And then you get an extra day just in case you forgot about it or something. And like oh shit, it closes tomorrow, but it was due today. That, if I don't have that extra day, it would be the 4th. The 3rd is Sunday. Okay. Okay, there we go. I give you that extra day because I found if I only had a deadline, everybody missed the deadline, and then they were like, hey, can I get a 1-day extension? And I had to deal with 75 million emails. Yeah, I actually don't have that clock button or the calendar button right now because PowerPoint is covering it up. I didn't want to have to hit the Windows key. That is me being super lazy. But it is currently covered up by PowerPoint right now. So I'm not totally incompetent, just sort of incompetent. But anyway, so that's going to be open. You don't have to do it today. You do get 2 attempts to do it. Do note that your quizzes are randomized, so if everybody is like, oh, let's all take the quiz together, you're all going to have different questions, so beware. Okay? But my advice to you before you take the quiz is make sure you've done the worksheets, done all the reading, done all the practice problems, and then do an attempt on the quiz. We will talk about scientific notation very briefly, just because I feel like that's the one thing that everybody has seen. What I will make a note of to do, though, is we're going to talk about scientific notation and sig figs, because scientific notation is useful for expressing numbers to a certain number of sig figs. Is the quiz hard? It depends on how well you've prepared. If you understand how to do these problems, you're going to be fine. That being said, you can't become an expert at doing sig figs and operations by just watching me do them. So do as many exercises as you feel is necessary, and then take the quiz. And remember, you get 2 tries. So if you think you're ready, take it once. See how you do. You don't get your score immediately. You get your score when I release all the scores at the end. But if you felt like, hey, that was easy, then you don't have to take it again. But if you want to be sure, you can take it a second time. That's what it's there for. I do want to thank everybody for coming out to the lecture. I did go over a little bit, but apologies for the stream going down. Tomorrow when we come back, we're going to go over those problems. We'll talk about scientific notation real briefly, and we're going to start Unit 3, which is dimensional analysis. If you're in the class Discord, make sure that you read about the announcement that I did for updating one of the pages. I have linked to the source material as opposed to a Canvas page, so all the weird formatting stuff should be fixed. Let me know if you find any other pages that are like that. And keep using the Discord. I see a lot of people in there, and that makes me really happy. Yeah, that's all I got. I will catch you all tomorrow, and we'll continue our lecture on Tuesday. Take care.